Hello, my name is Cole Patterson. I'm a construction science and management major here at Texas State University, and as of this summer, I am beginning my senior year. Today I'll be giving a presentation over piles and pile driving equipment. So just to get into the outline of what you all can expect from this presentation today, first three slides, the last, this current, and the next, we'll be going through some introduction material, followed by related equipment, piles, and what they are, what they consist of, and then the cost related to piling operations, followed by related safety, pile driving techniques used throughout Texas, a conclusion/summary, references, and then knowledge check 1 through 3. So just to give an introduction on pile driving, most people that have a little bit of a brief understanding of construction know what pile driving is or have some sort of idea of what pile driving is. It's a technique or method of foundation, anchoring, and or construction that's been around since steam-powered machinery was in use. Nowadays, the steam-powered has went out the door. We are in the mechanical age and have been, or the industrial age and have been for a very long time. Nowadays, pile drivers are mechanically driven using hydraulic cylinders and various technology. Nonetheless, just to give a brief explanation here, without reading off the slide verbatim, pile driving is used heavily in heavy civil or the civil sector of construction, and a good bit in commercial construction as well. Not so much in residential, but you'll see pile drivers used in coastal coastal construction quite a bit. You'll see it in highway and bridge construction. You'll see it in cofferdam construction, which I will touch on a little bit later. And regardless of where it's being used or what sector pile driving is being used in, the method or end result is always the same. You are pile driving to create an anchor point between your structure that is to be built and the ground, rock, or level earth, stable earth, anchoring material in your given location or job site. So typically, to get to your more of your anchoring material, you have to, and this depends a lot on geotechnical conditions and soil type, et cetera, and I'll touch on that a little bit later. Nonetheless, you need to drive down pretty far. So typically, you will either drill, and you can use drilling as a method for piles, or you will do a mechanically driven pile. And drilled piles are becoming much more popular nowadays just due to the reduced noise and vibrations. But at the same time, you'll still see mechanically driven piles. But regardless of the type or machinery, pile driving is elevating a head or a hammer, a very big hammer or weight, to a specific height, and then dropping that weight on a wooden and or timber typically is the wood type, steel or concrete pile, and repeating that process until the pile has reached its required depth. So the related equipment behind pile driving, you have the pile driver, which we have over here in these images to the right. You have the pile hammer, which is that upper right hand image. That is actually going to, I guess I could dive into the pile driver itself. Pile driver is typically going to be a crane nowadays that holds a, I guess you could say, platform setup that will support the pile and hold the hammer head. which will raise and fall repeatedly to drive that pile home. And that hammer head is typically either a weight that is elevated and dropped repeatedly, or it is a vibratory device that will vibrate at a certain level, which can be controlled until that pile is driven. So pile driver, the machine that drives piles into the earth. Pile picture to the right, as I said before. Pile hammer there in the upper right hand corner delivers the force needed to drive the pile into the ground. Typically, as I said, you will have the setup, the railing system for the pile hammer and the arm / chamber that will hold the pile itself, regardless of the material that pile is made out of. I'll touch on those materials and types of piles in the next slide. To do that and hold all that up in place, you'll need either a crawler crane, which is pictured in the right, or pictured to the right, or a rough terrain crane, typically a crawler crane. Something with a decent enough counterweight to counterbalance the forces that are exerted by that pile driving operation. So your crawler crane or crane in general, rough terrain, etc., will help to guide the pile into its hole and aids with stability. And last but not least, flatbed trucks or a lowboy truck, just to help with the transport of the equipment, the crane, and specifically the pile to the site. Some other material, or not necessarily material, but machinery that's not mentioned here, be a wheel loader or forklift, front end loader, that will position the piles and or material, move things around the site of the pile driving operation, just to make sure everything is in place and ready to go. And at times, water trucks or a water tank to help cool down the pile and aid in dust suppression. So piles, what are they? Over here to the right, in the lower right-hand corner, you have steel. Next to those, a little to the left, you have timber. And upper right-hand corner, you have concrete. These are going to be your three types of piles. Any pile in the world, all around the world, throughout the United States, are going to be one of these three materials. So piles are vertical structural elements used as a deep foundation to support structures, particularly in areas with weak or unstable soil. They are essentially long, strong columns, often, again, made of concrete, steel, or timber, that are driven or drilled into the ground to reach a more stable layer. And again, you have steel, concrete, and wood. And I will touch on this a little bit later in the presentation, but your steel piles are very strong. They last forever. Not forever, but they last a very long time, longer than steel or concrete piles, but they're very expensive and they're very heavy. Concrete piles also last a very long time, but you can only use those in certain conditions. They're also very heavy, and they're not cheap either. However, concrete piles are the most common nowadays. And last but not least, you have timber piles, which are very cost effective, but they're not durable, and you can only use them in very, very limited applications. So I think, just to put it into terms or create a visual, you think of a pier at the beach. I think most of us have been to the beach at least once in our lives. You have piers where you walk out, fish, take pictures, etc. Those piers are typically supported by wooden piles. So the cost, touched on this in the slide before. Nonetheless, you can read through this a little bit, but you have your wooden piles, again, the cheapest. They are usually $150 to $250 per meter. PPC, which is the technical term for concrete piles. That stands for precast, pre-stressed concrete piles. They're usually $200 to $350 per meter. And for those of you who don't know, pre-stressed concrete, precasted concrete, this is concrete that has been pre-tensioned prior to the pour, which helps with tensile strength and tensile forces. And it is concrete that is assembled and or cast off-site, usually in a factory operation, assembly line type operation, and then brought to the site via flatbeds, transport vehicles, etc., and placed in the fashion that it's needed. You have pre-stressed concrete that comes in all shapes and sizes, but most concrete piles are, if not all concrete piles, are pre-stressed. And last but not least, we have steel piles, which have the highest unit costs, ranging from $250 to $400 per meter. But steel is very durable, very long-lasting, and has the widest range of applications out of all piles. You're usually going to see steel piles used in high-rise building construction and with the construction of bridges and embankments. Very expensive, very heavy, but they last. Concrete piles are also used in a lot of infrastructure work as well. And again, as I mentioned before, timber piles are usually only used in coastal applications, a lot of the time with piers, some minor flood walls, water mitigation systems, and briefly residential construction, coastal homes or homes that are built on the coast and elevated constructions just to avoid flooding. A lot of times those will sit up on wooden piles, but wooden piles are very uncommon because they do not last a long time and they're very susceptible to weathering and rotting, etc., etc. Wooden piles are inadequate when it comes to civil or commercial construction, mostly due to the weight constraints that are involved and forces being exerted onto those piles. Nonetheless, moving on to related safety in any pile driving operation, you have vast safety requirements and or OSHA requirements as any construction operation. But pile driving, especially just because of the noise that's created by the vibrations or the hammer dropping on the pile, you have a lot of safety measures in place. Everything from earplugs, safety glasses, hard hats, PPE, restraints, harnesses, barricades to block off and or fencing to block off the pile driving operation from other areas of the site and or civilian traffic. Generally, the same type of safety requirements that are required and or used throughout most construction projects, regardless of the sector, but a little bit added ear protection and environmental protection as well, especially in your coastal environments, to control runoff, manage dust, and in any pile driving operation. Your noise pollution or noise mitigation is going to be very important. So, gotta be mindful of your surrounding area, the surrounding site. Is the area residential? Is it commercial? Is it rural? Are you working next to a road that is occupied, et cetera, et cetera? These are all different things that are taken into consideration during pile driving operations. So, pile driving techniques used throughout Texas and the southern United States / the United States in general, throughout the world. Pile driving, as I've described it up to this point, is very common still. You'll see it used in a lot of coastal construction, a lot of building, high-rise construction. You still use piles, whether they're steel or concrete, again, typically steel. But nowadays, and this is very common in civil construction with bridge embankments, bridge bents or piers that will hold your elevated roadways or your interchanges, your bridges, etc. We have what you call drilled piles. So a drilled pile is a little bit different, actually a lot different than a regular hammered in or vibrated pile. Typically with a drilled pile, the process goes as follows, or it follows this procedure. You will drill, you have your geotechnical report, and geotechnical report or soil analysis done by a geotechnical engineer. That's going to be necessary in any piling operation, regardless if it's a drilled pile or a vibrated pile or a driven pile. You need to know what type of earth you are installing your structure in. So that'll give you a much better idea of what to expect, the resistance, the depth that you need to drive the pile to, et cetera, et cetera. So again, back to drilled piles. I've explained, mechanically driven and or vibrated piles enough, but I haven't touched on drilled piles a lot. And being a heavy civil individual myself, I currently work for a company named Austin Bridge and Road, and I'm on a highway project with them down in San Antonio where we are employing the drilled pile method with all of our what we call bents, which are the columns that support the superstructure of our elevated roadways or bridges. So typically how this goes is we will drill a pile. It's either a singular hole or you have double holes for your straddle caps, which are going to be, columns on either side with a cap that will straddle those two columns. But for the sake of this presentation, we will just speak on the singular pile. So you'll drill down to a depth, usually hitting your limestone or bedrock limestone here in Texas. Drill through all your loose and nasty soil to get to an anchoring material that you can tie into. Once you've gotten to that depth, you will place a rebar cage in the hole, followed by a steel liner, and you will pour concrete, you'll backfill concrete up to the top of the hole, right? And once you reach that, the excess liner or casing and or rebar is cut. You pour what you call mud slab, which gives your column a stable surface to build its slab off of and tie into the rebar below from the cage. And from that point on, you go vertical with your column, which will then again support your girders and or superstructure of the bridge or elevated roadway. Though it is different, and is very different for that matter, it's still considered a drilled pile. So just wanted to touch on that because you have a lot of drilled piles used throughout the state of Texas and most of the southern United States. Typically, depending on projects, of course, very common, and again, in highway and heavy civil work, you see drilled piles all throughout the country, not just Texas. So, conclusion / summary. I appreciate you all for bearing with me in this presentation. I know this isn't the most illustrious information, but regardless if it's a hammer-driven pile or cast-in-place system, wood, steel, concrete, or rebar cage, piling methods are all around us in every sector of construction. They come in all shapes, sizes, require different methods of installation, and are vital to the foundations of various structures. Hopefully this presentation was able to shed some light on the importance of piles and pile driving methods used throughout construction. I really do hope that you all took a little bit from this presentation as we wrap it up. Piling is so important. Your foundation is everything in construction, especially commercial and all construction. This applies for residential as well, though piling isn't used widely in the residential sector. But the same the same principle applies. you got to have a strong foundation to build. And piling makes high-rise buildings possible, makes bridges possible, highway systems with elevated roadways and embankments possible, as well as a wide variety of other structures, cofferdams, flood walls, beach piers, etc. Piling is very important. If that's the one thing that you all took from this presentation, I did a good job. So here are just some of my references that I used. I sourced information regarding piles and or cranes and images of cranes and piles from Biggie Crane, Keller North America, which is a big-time geotechnical and or foundation, mainly foundation work, general contractor. You'll see a lot of their work all around the state of Texas, actually. For those of you that are native or familiar with the Austin area, there's currently a highway project there on 183, and Keller is doing a lot of the drill work and or foundation for those columns and or bents that are used throughout that widening and or modification project. And they work all over the country. Very credible source, and I use them for pile driving information and images. Also used the FHA, Federal Highway Administration, for a cost analysis of pile driving, just to get some of the accuracy down to a T, as well as Builder Connect for more cost information and pile driving information. And last but not least, Google, mostly for some pictures and also brief amounts or small amounts of information. Now, moving on to our last three slides, four if you count the final slide, but we'll get to that here in a little bit. Knowledge check 1 to 3. I know the answer is there already, but bear with me. What is the most important pre-construction requirement needed in piling operation? That's going to be your geotechnical report. So your geotechnical report is done by a geotechnical engineer and or engineering firm like Terracon, for example. And that is an example of one is right here. You will have all your specs for your project or your structure, and will give you the soil conditions, the soil type, the depth that you are required to bore and or drill, pile, dig, etc., to the point where you are stable for your structure and have reached an adequate level. It will also give you information regarding the water table and other key important details regarding whatever structure and or foundation you are trying to build. Knowledge check 2 or 3. What is the most common type of pile used on bridge and highway projects around the United States? I hinted on this earlier in the project or in the presentation. My apologies. It's a cast in place drill pile, and that rig pictured there to the right is actually drilling for a cast in place drill pile on a highway project. So explained that operation earlier. This is a more efficient and less detrimental way, at least to the environment, way of driving piles and or creating foundation anchor points. And you especially see drilled cast in place piles throughout the southern United States, in particular Texas, because of the high concentrations of stone and or limestone in our case, but stone throughout the southern United States. Also, drilling allows you to reach deeper depths than general piling, mechanically driven piles, so or hammer, regardless if they're hammer or vibratory piles. So cast in place drill piles are the way of the future and have been a mainstay in construction, especially heavy civil construction, highway construction in particular, for a long time, and will continue to be used. Last but not least, knowledge check 3 of 3. To the right is one of those Keller images that I spoke on earlier from their website. But knowledge check 3 of 3. What type of piles typically used in cofferdam construction or water-related shoreline project, and that's going to be a sheet pile. And to give a brief definition of what sheet piles are, this again is a really good image of them. Sheet piles are going to be steel plates that are very thin, long, and wide. They provide a seal or temporary barrier / dam, and they're going to be used in aquatic / coastal operations. So a cofferdam is actually a temporary structure typically used to cast and or build piles or bents, columns for bridges that cross spans of water. Those cofferdams are made up of several multiple sheet piles that are driven by a vibratory pile driver. And you can also use them to build. A cofferdam is a temporary dam, hence the name. But you can use them to create flood walls, drainage canals, temporary and or permanent structures. And they are a very common type of pile, even used to this day. Having a little bit of trouble here with my last slide, but sorry. But I guess this is the end. At least the issues were eliminated or limited, for that matter, until the end. Nonetheless, thank you all. Feel free to drop your questions down below in the comment section. Gave you guys an image of a vibratory pile driver here to end things. But thank you all for listening to my presentation over piles and pile driving equipment. Y'all take care.